Greetings to all of you. In today's session, we are going to discuss about the intermediate chemistry will be helpful for your international entrance or any competitive exam you are preparing for. In addition to this one, India level, JEE Advanced, JEE means for IIT and NIT entrance examination, need chemistry for medical entrance, and Telangana, Andhra Pradesh MCET examination for engineering entrance. In addition to all this, if you are aspiring for any government examination, you have to attempt the general science, general studies question paper compulsorily. In that, the content like what general science will be there, the topics what we are discussing will be very much fetching towards that kind of examination. Let's enter into our today's session. Explain the name of the following compound as per the IUPAC protocol. IUPAC naming of the compound we need to assign, and this is a compound said to be spiro. Any compound having bicyclic ring system and the joined by one carbon is a common one. So the joining carbon used to connect two ring systems, which is called a spiro. So another bicyclic system will be there. The fused ring will be there by two carbon atoms. That is called bicyclic. There is a slight distinction between them. Spiro compounds are joined by only one carbon. Fused bicyclic systems are joined by two carbon atoms. Here, these two rings are joined by one carbon so that we can say it is a spiro compound. And this spiro compound is having two double bonds and in either methyl side chain. We need to give the appropriate name for the given compound as per the IUPAC. IUPAC stands for International Union for Pure and Applied Chemistry. Let's see how can we give the numbering. In order to assign the numbering for the system, we have to go for where the substitution is there. In that direction we are moving, and 1 2 3 4, the bridgehead carbon will be given with the fifth one, sixth, seventh, eighth, ninth, 10th. Why we are moving this side? Because here is the double bond, no? That's why after 5, number in 6 will come this direction only. This is the way numbering will be given: 1 2 3 4 5 6 7 8 9 10. Total 10 carbon, 2 ring containing system it will be. So the deca will be the parent skeletal chain, and in this you can find two double bonds located in between 1 and 2, 6 and 7, right? And methyl substitution is assigned on second carbon atom. Let me give the entire name for the given compound, that is 2. On the second carbon, we have methyl, no? So the 2 methyl, let me assign. And it is mentioned like a spiro. Being it is the bicyclic or two ring systems combined with one carbon as a common. So that spiro is the name. Within the bracket, what we have to assign, what we have to mention. So here, how many carbons are there in the one side? How many carbons are there in the either side? That to be mentioned, 4, 5. And the parent skeleton is a deca. And in this molecule, you can find the double bonds on the first and sixth carbon atom. 1, 6 diene. This is the entire name. Methyl, sorry, 2 methyl spiro, 4, 5 deca, 1, 6 diene is the complete name of the given compound. Here is the definition provided for spiro compound as per the Wikipedia. Organic chemistry, spiro compounds are the compounds having at least 2 nuclear rings. If you see these 2 nuclear rings are connected and they are having one carbon atom as a common one. This carbon is common for 5 member as well as 6 member. So that this is said to be a spiro compound. This kind of definition is provided by Wikipedia, spiro compound. Right? So this is the entire name for the system which is provided in the option number D. So 2 methyl spiro, 4, 5 deca, 1, 6 diene. For question number 1, option number D will be the correct answer. Move on to question number 2. Question number 2 is collected from Cambridge Assessment International Education. When molten lead bromide is electrolyzed using platinum electrodes, what is obtained at electrodes? So two different electrodes are there. Both are made up of platinum only. And lead bromide is a compound taken, lead 2 bromide, sorry. Lead 2 bromide was taken and subjected to the process of electrolysis so that lead will be deposited at one electrode, bromine will be evolved at another electrode. So that will be possible. Negative electrode having shiny gray liquid, positive electrode is having bubbles of brown color gas. Let's see how can we get this. This is a kind of entire device where electrolysis process can be carried. A container can be taken. In the container, molten lead bromide was taken. Lead bromide under molten conditions, liquid melted form you're taking, so that there is a possibility of lead Pb plus 2 will be ionized and the bromide ions Br minus will be formed. This is a kind of ionization process and the aqueous or molten condition. Whenever electricity is supplied to them, bromine having susceptibility to release the electrons to the uh, positively charged electrode, and Pb plus 2 having natural tendency to accept the electrons. Two electrons will be accepted. Here you can clearly see. So that lead by accepting electrons converted into metallic lead. Bromide ions by releasing electrons converted into non-metallic gaseous bromine will be generated. Bromine gas we can say, right? This is the way bromine gas evolved here, and lead metal will be deposited on this electrode. So negatively charged bromide ions move to the positive anode and bromide ions loses electrons and converted into bromine atom. That is a bromine gas. Positively charged lead ions move to the negative cathode and each ion gains 2 electrons to form metallic lead. This is the way you can see metallic lead is formed, and being it is aqueous solution, shiny gray liquid will be generated. And here you can find bubbles of a brown color gas will be generated at the electrode, at this electrode. So this is the way we can give the electrolysis process for lead bromide. Uh, Move on to question number 3. Question number 3 is a kind of problem which is given from the fuel cell. So it is a kind of fuel cell, we can say electrochemistry related question. Consider a 70% efficient hydrogen oxygen fuel cell working under standard conditions. Standard conditions denotes 1 bar pressure, 298 Kelvin temperature. Its cell reaction is hydrogen gas plus half O2 gas gives rise to water as a liquid. This is a kind of simple hydrogen oxygen blend to give water as a product, where hydrogen oxygen fuel cell is working based on this kind of redox reaction. The work derived from the cell on the consumption of 1.0 into 10 power negative 3 moles of hydrogen gas is used to compress 1 mole of monatomic ideal gas thermally insulated container. What is the change in the temperature of the ideal gas? Change in the temperature delta T to be determined. Del T we can say. The standard reduction potentials are provided. Oxygen by gaining 4 H plus ions, consequently 4 electrons, 2 water will be generated. For that, standard electrode potential is 1.23 volts. Hydrogen by gaining electrons or losing electrons converted into hydrogen gas, so that standard electron potential of hydrogen always orbitally fixed as 0, so that hydrogen electrode potential is given as 0, oxygen is given as 1.23 volts, and the Faraday value is given 96,500 coulombs per mole, is equal to 8.314 mole inverse Kelvin inverse. So this is the data we have here. Del T to be determined. Change in the temperature is called del T. For that purpose, again, we are writing the equation once again. Hydrogen half O2 by gaining 2 electrons, formation of water is possible, where 1.23 volts of current will be generated. This is the standard electrode potential of this entire fuel cell. For this gives a free energy del G naught. Del G naught is equal to negative NFE naught cell is equal to N denotes what? Valency, how many electrons got transferred. Electrons accepted are released, accepted by cation are released by anion. Remains 2, so that N value can be taken as 2. F is the Faraday value. Just now we saw Faraday value is 96,500. 96,500 will be taken into 1.23, 1 into 10 to the power negative 3. 1 into 10 to the power negative 3 is the work derived cell consumption. These many moles of hydrogen gas consumed for this reaction. This is about the number of moles hydrogen gas consumed for the reaction. We are taking that one. Okay. So 0.7 will be taken, is equal to. So when you multiply all these, E naught value is there. E naught value is given as 1.23 volts. That 1.23 volts we substituted. Faraday value we substituted. And this is the number of moles of gas what we are taking. Number of moles of gas what we are taking. We are using that one as well. So that delta G value is calculated as negative 166.173 joules. So this is for what? 1 mole. So they mentioned the 1 mole. So negative 166.173 is called delta G. Then W is becoming 166.173 joules. Okay, it's negative convention got positive for W. So W is equal to, we have another formula in thermodynamics. W is equal to N R del T by gamma to the power 1 minus 1, sorry, gamma to the power minus 1. N R del T by gamma to the power minus 1 will be there. W value already known, that is 166.173, and N. So N value is taken as 1 over here. R is the gaseous constant whose value is 8.314, that is mentioned over here. The del T to be determined. Gamma value is 5 by 3, negative 1 can be taken. So if you take all these except the delta T to be calculated, delta T is equal to this 166.173, whatever denominator is there that will come up, and multiplied with the 2. Whatever numerator terms are there that will come down, 8.314 into 3. So if you do this calculation, the value of delta change in the temperature is 13.32. Being it is a temperature change, and 13.3 value, 13.32 value will be taken. This is the way we can go for the calculation. For question number 3, 13.32 will be the temperature change for the given gaseous system. This is for what? Hydrogen oxygen fuel cell. Here one point I would like to mention, hydrogen to be considered as a fuel of future, and being hydrogen oxygen fuel cell is a clean energy source and the most widely applied in the fuel of rockets, and most of the devices with a high efficiency. That's the reason why this kind of discussion or practicing the questions based on this will be very much important. Move on to question number 4. It is based on what? Radioactivity of elements. Nuclear chemistry, we can say the content contrived from nuclear chemistry. Uranium 92 to 38 is known to undergo radioactive decay to form final product lead 82 206 by emitting alpha, beta particles. A rock initially contained 68 into 10 power negative 6 grams of uranium 92 to 38. So here, how many grams of initial weight of uranium 238 is given over here. If the number of alpha particles that would emit during the radioactive decay, uranium to lead in 3 half cells are Z into 10 power 18. So here, number of alpha particle emitted, that number we need. How many alpha particles emitted during the conversion of uranium, starting material to product? In 3 half cells. In these, the entire 3 half cells is given by Z into 10 power 18. So Z value to be determined. What is the value of Z? We have to identify. Z value to be calculated as 1.2. We have to find out how can we get this 1.2. It is a question given from nuclear chemistry, and again it is the kind of problematic session. Uranium 92 to 38 gives rise to final product later, they said. So whenever final product lead 82 with a 206 atomic weight, the difference in this atomic number is 10. Atomic weight difference is taken as 2, 3. 32 difference will be 3. Okay, 32 atomic weight difference, 10 is the atomic number difference. In order to accomplish that, 8 helium nothing but what? Alpha particles, and beta particles are 6. These many are required. Alpha particles are 8, beta particles are 6 are required. Then we can accomplish the entire atomic number and atomic mass difference between them. So here number of moles they gave, but within the problem what they said, the weight of uranium they gave as a data, statistical data, weight of uranium that is 68 into 10 power negative 6. If weight is known to you, how can we convert into moles? Number of moles is equal to weight by gram molecular weight. Weight is known to you, that is 68 into 10 power negative 6 by gram molecular weight is equal to 238. So we will get moles as 0.286 into 10 power negative 6. This is for number of moles of uranium. Okay. So if number of moles are known to you, converted into number of molecules, how many alpha particles they are asking, number of molecules required. In order to get number of molecules, moles can be multiplied with Avogadro number. N denotes what? Avogadro number. Avogadro number value is constant 6.023 into 10 to the power 17. So when 0.286 into 10, 6.02 into 10 to the power negative 7 is multiplied, we will get the number of alpha particles, that is 1.72 into 10 to the power 17. 1.72 into 10 to the power 17 we got. Okay. So this is the way Z value will be calculated. So for question number 4, this 1.7 into 10 to the power 17 is the correct answer. Move on to question number 5. Question number 5, we have identified the correct plot of the wave function associated with the particle in one-dimensional box at the quantum number n is equal to 3. For here, the condition required is particle is laying in one-dimensional box. In that, wave function to be determined, and the quantum number is given as n is equal to 3. It is somewhat a simple representation. If wave function n is equal to 1, n is equal to 1 if present, that wave function is denoted by only one curvature. One curvature indicates n is equal to 1. If n is equal to 2 is there, the curvature is like a upside. That means a peak and a trough. Both you can notice. This is called peak, this is called trough. Okay, peak and trough we can notice, or else you can say this is hill, this is valley. Okay, in either of the way you can pronounce this. And if n is equal to 3 is mentioned, one peak, one trough, another peak. This is the way alternate arrangement you can notice it is the simple representation. Psi 1 with a one peak, psi 2 with a peak and trough, psi 3 with the two peaks and one trough. This is the way representation is possible. This is applicable to particle in a one-dimensional box. N is equal to 3. The correct answer will be this third one. This is the right representation for wave function. This is the question contrived from the Telangana Gurukulam Degree College lecturer entrance examination. So this is the way we can clearly answer about, and move on to question number 6, which is the last question of the session. From the figure shown below, identify octahedral and tetrahedral voids. How many octahedral, how many tetrahedral voids are there? We need to identify. In order to identify them, first of all, we have to see condition for tetrahedral, condition for octahedral voids. First point only make the clear sense in order to answer this one. A single triangular void crystal is surrounded by 4 spheres and is called a tetrahedral void. If 4 spheres are surrounding, when 4 spheres are surrounding, that is called a tetrahedral void. If 6 spheres are surrounding, that is called octahedral void. Okay, 4 spheres tetrahedral, 6 spheres octahedral. So let's see. If you see this, so above you can notice the two lobes are there. In the same way, in backward direction also, always there is another face to the coin, right? So that we can say these two lobes also accompanied with the two other lobes backside. So whatever void is there in between, that is noticed like a tetrahedral void. 2 plus 2, 4 lobes in between vacancy, in between vacuum is said to be what tetrahedral void. In the similar manner, here also you can find the two lobes. Two lobes are there, and the exactly backside you can find out another two lobes. 2 plus 2, 4 lobes. So when four lobes in between gap is there, that is said to be another tetrahedral. So that A and B clearly denotes what a tetrahedral voids. These two are tetrahedral voids. And if you go for 1, 2, 3, you can notice three lobes are occupying over there. And whenever three lobes are towards you, exactly opposite direction, in either three lobes will be there. Three front, three back, total 6 lobes are there. If 6 lobes are connected with a particular vacant site, that site is said to be what? Octahedral void. In the similar manner, here also for D, here one lobe is there, here second lobe is there, here third lobe is there. Three again triangular lobes you can clearly notice like this. In the same direction, in the same kind of orientation, you can notice in opposite direction, backside also. So that this D is also the kind of 3 plus 3, 6. In between 6, whatever gap is there, that is said to be octahedral void. So that C and D designated as octahedral voids. A and B are mentioned like a tetrahedral voids because AB, if you see AB like this. Here only two lobes, backside two lobes. Here also two lobes, backside two lobes will be there. But in case of C and D, you can see three lobes are connected like this. So that we can say A, B are clearly mentioned for tetrahedral voids. C and D are clearly indicated for the octahedral voids. This is the way we can clearly understand. How can we explain this one? This is about tetrahedral and octahedral voids. A question given from the what solid state chemistry. Fine. So by this, we entirely completed the session. Different dimensions got covered over here. IUPAC nomenclature taken into the consideration. Organic chemistry questions are there. Polymer chemistry taken into consideration. Physical chemistry topics, quantum chemistry, atomic structure. So many dimensions of intermediate chemistry got undergone with the detailed explanation. Hopefully, the session will be really informative to everyone who are watching this one. And if you go for any kind of comments, sharing, like, so that we will go for more such kind of quality content over here. That's the reason why I'm sincerely requesting all for encouragement by commenting over there and like the channel and sharing with other aspirants who are seriously preparing, and subscribe the channel in order to receive more such updates and more content which is really informative. Thank you very much for your patient listening. Thank you one and all.